Hello, and welcome to Fundamental University Physics. This here is the text that we'll be using. This is Fundamental University Physics by Alonso and Finn. This is a 3-volume set from the 60s. As far as I can tell, they're currently out of print. This is what we're using. The main reason we're using this is, well, there's a couple of reasons. One, I think aesthetically it's just better than some of the modern bloated textbooks. It's smaller, it's more compact. There's not a lot of extra fluff or margins that are not used. It bugs me that there's so much extra space inside a modern textbook. I like that it's broken up into 3 volumes so that this, is about a pound. It's not a 10-pound textbook covering all that. It's a very rigorous text. It's very strongly rooted in math and problem solving and things like that. So it's very comprehensive as well. It covers every topic in undergraduate, early physics classes, all the way up through modern physics. That's why we're going to be using this text. Also, again, main reason I'm using these is I found them for $1 each at a thrift store, which is a bargain considering the physics hasn't changed at the undergraduate level from the 60s to today. So really, really high quality, very durable, very long lasting, very nice and information filled textbooks that I just think are really neat, and nobody else is really covering them. Nobody's using them for classes because they're out of print. So I'm not going to be in danger of solving your homework for you and things like that. How this is going to work, we're going to start out at least with a weekly video added onto this playlist, and it will alternate between a video that covers some of the text material and then a video of problem solving related to that text that was just covered. I'm not going to do a separate video for each individual section within each chapter. I'm going to try and break each chapter up into 3 or 4 videos where I'm explaining things, which should cover about an hour to 2 hours maybe of lecture type video where I'm explaining what I've just learned from the text. And then there should be about an equal amount of problem solving videos for each chapter. Who's this for? So of course, if you just need info about a particular topic, feel free to go find that topic in the playlist and watch that video. If you need to learn better about the vector cross product, that's great. Go watch the cross product video I'll be making. If you need to learn about angular momentum of rigid bodies, go find that video and watch that. That's great. I don't mind that at all. If you are learning mathematical physics, either in a self-study program or in a university setting, then you may benefit from watching the entire playlist over the course of your courses in class as a supplemental material. Or again, I'm trying to treat this more like not me teaching you things, but more like me leading a study group. So hopefully, I hope that's the vibe that ends up coming out from this. I'm not going to separate videos in playlists of problem solving or lecture type videos. I'm going to keep them together right up next to each other, again, because I want to focus on problem solving, and I want the problem solving to be as related to the most recent text as possible, just to help cement it in my brain, and also maybe it'll help cement it in your brain as well. If you have any questions, you need any clarifications, you want to suggest problems for me to do, anything like that, feel free to leave a comment in the video that's relevant to it. I'll answer comments back as quickly as I can. You may be able to help direct future problems or videos or extracurricular topics that are related. So now this is a very long project that I'm going to be doing. This is, like I said, it's 3 whole volumes. It's basically at least 3 semesters worth of college level physics courses. We're going to take a very slow and methodical pace through it. Like I said, 3 or 4 lecture videos per chapter, spaced out with a video at the start, at least, with a video coming out every other week with lectures. So the first chapter I think I'm doing 3 videos, so that's 6 weeks to do the first chapter. Very long project. I'm not going to be trying to rapid dash through the entire physics curriculum. This is intended to be slow and methodical so that it has a better chance of sticking in my brain rather than just blasting through it and saying, oh yeah, I know vectors, oh yeah, I know torque, oh yeah, I know kinematics, I need to get right to electricity and magnetism, and oh wait, I don't know mechanics and I don't know kinematics, and how do you do the scalar products again? Not what I want to do. So we're going to take it slow, spend some time at every step along the way, make sure we really understand things. We're attempting to learn mathematical physics, not pass a test on mathematical physics. Absolutely try all the problems that I'll be performing yourself. Pause the videos right after I pose the problem. So for each video, hopefully I'll have the brain space to make lecture notes for the lecture videos and problem sets that cover both solutions to the problems that I do on the board and maybe a couple of extra problems in a similar vein, or maybe a little bit harder, a little bit different, just something so that you have something else to work on. There'll be problems that I'm also doing myself, so it's not like I'm giving you extra stuff that I'm not doing. But that will hopefully help you guys, and it'll get me a good habit of typing up the things that I've learned and stuff like that. Hopefully this slow pace with all the resources that we've got that we'll be doing, hopefully that will get us confidence, get us stronger foundation of what we're doing, so that once we get to the next step that's more complicated, it's not more difficult. It's not intimidating, and not going to keep us from going forward because we don't have that confidence in ourselves or that foundational base. So subscribe or save the playlist to your library if you want to learn mathematical physics with me, especially starting with fundamental university physics. And be sure to check out this other playlist on Thomas's calculus as well.